This is the forest of our imagination, lush, green, a symbol of life, with the feeling that it has always been here, that it will always be here. But what if it's more fragile than we think? What if it could all be gone in the blink of an eye? How could a forest die this fast? The culprit wasn't a fire, it wasn't a storm, it was an army whose soldiers are no bigger than a grain of rice. This is the story of how a tiny beetle, amplified by a changing climate, rewrote the map of Europe's forests. Let's travel back in time to over a century ago. To fuel a growing economy, vast swaths of the Czech Republic were planted with a single fast-growing tree, the Norway spruce. A perfect tree for timber, but it created a homogeneous, vulnerable landscape. For decades, this vulnerability was just a risk. Then came the trigger. A series of hot, dry years peaked in 2018, leading to a historic drought. The trees were stressed, their natural defenses were down, and they couldn't produce the sticky, defensive resin they needed to fight back. The forest was weak. Meet our culprit, the Eurasian spruce bark beetle, Ips typographus. It's a native species, but the combination of endless food and weakened trees created the perfect conditions for the population to explode. They swarmed, burrowing into the spruce, laying eggs, and cutting off the flow of nutrients. The results? A tidal wave of tree death. Since 2018, the Czech Republic has become Europe's disturbance epicenter. The scale of the outbreak was staggering, affecting an estimated 100 million cubic meters of timber. Scientists couldn't just walk through this disaster zone. They had to go to space. Using years of satellite data and advanced artificial intelligence, they mapped the damage in unprecedented detail, training a computer to see what they couldn't. Every single patch of dying forest, year by year. The data revealed 7 major outbreak hotspots. One area in the heart of the country, codenamed C4, became the core disturbance zone, a ground zero spanning a staggering 9,000 square kilometers where 38% of the forest cover was lost. The damage wasn't just dead trees. The very fabric of the forest was torn apart. The landscape became severely fragmented. Before the outbreak, the average forest patch in this core zone was a sprawling 272 hectares. By 2022, it was just 8 hectares. The forest had been shattered into 1,000 disconnected islands. But the data from space only tells half the story. To truly understand the aftermath, a team of researchers from the Czech University of Life Sciences went to the front lines.
It's really been wonderful being out in the field and getting to see firsthand what disturbed forests look like, what undisturbed forests look like, what forests under different management regimes look like, what unmanaged forests look like.
After 1 year of no field work, doing field work after a desk-based job was great. I cannot describe the feeling, like working in the sun and in the woods and experiencing the European forests and all.
It was great to come back to the field and work because we all got interested in the field of ecology, not because of codes and R and Python, but because of the field itself.
5 years after the peak of the devastation, the team set out to find what happens after a forest dies. What does recovery look like?
It's a very interesting site also, the one that we visited yesterday, because It's a heavily salvaged site because it was very disturbed by the bark beetle infestations towards the end of the last decade. And 5 years since, it's nice to see that the forest owners have adopted scientifically sound strategies to manage these forests.
They found a landscape in transition. The new forest is young, and as Maya notes, its vertical structure is poor. But there are signs of hope.
We visited several sites that you probably have seen before, and we were tracking down the forest recovery, like what species are present, what is their vertical structure, and if they have some damage in terms of pathogens, or if there was some browsing occurring, or potentially some other defoliation stuff. So we were kind of concerned about their health status, and also if there is any regeneration present. And we are quite lucky because we found very nice samples. The vertical structure is quite poor because all of them are quite small, but then we've got nice signs of the remaining deadwood.
The outbreak also created a unique, large-scale experiment. Here, Professor Tomasz Halasny explains the contrast between the two different philosophies for the future, separated by a single road.
We had here very interesting situation where on the left side of the road we have actively managed forests which were undergoing reconstruction. It was originally spruce forest planted here, which was historically planted here, but now these forests are suffering from problem with health issues and they are simply not fit to these conditions. So there is ongoing something what we call conversion of this forest, like change of species composition to something more stable, resilient, adapted to climate change. And on the opposite side of the road, we had nature reserves. It is called Žákova Hora. It's Žák's Mountain Nature Reserve, and it has a size of some 30 hectares. And it's very interesting to see the contrast between left and right side of the road.
And what does that more natural future look like? It might not be a spruce forest at all.
Our PhD student Marco is doing experiment. He's there. He's doing experiment on how long it takes after stopping or ceasing the management in a previously managed forest to restore biodiversity of different taxonomic groups.
Here you can see how basically setting aside the management and lets the natural vegetation grow will replace these Norway spruce plantations. So here you see big trees of Norway spruce, but all the regeneration is European beech, and this will be beneficial for the biodiversity.
The scientific study that mapped this devastation calls it a glimpse into the future, a warning of what could happen in other regions as climate changes. The outbreak was a catastrophe, but it is also a chance to reset, a chance to move away from the vulnerable monocultures and build more complex, resilient forests that can withstand the challenges of a warming world.
I speak for myself, but I think I can safely speak for everyone when I say that it's been really insightful. We learned a lot and we also had a lot of fun. So it's been entertaining and informative and just an overall wonderful trip.
The Billion-Beetle problem has left deep scars on the landscape, but in its wake, it has also cleared the way for something new. It has forced a conversation about how we live with nature and provided a tough but valuable lesson on how to build a forest fit for the future.